Hello everyone. Welcome to lecture 6. So far we have studied in this course. So far we have studied about definition of AI, agents, how to model AI problem as a as a search problem. Then after modeling our AI problem as a search problem, we needed to find the solution. So for that we also talked about the search strategies or search algorithms. So so far we have studied various search algorithms like BFS, which uses the queue as a frontier, DFS we talked about, which uses the stack as a frontier, and then after talking about the BFS and DFS, we talked about two variations of the DFS, so-called DLS, depth limited search, and IDS, iterative deep search. So these two are kind of like a variations or of DFS. So we talked about these algorithms so far. So you realize that all the algorithms that we have discussed so far, like BFS, TFS, and these, these algorithms doesn't include path cost. So for example, so far whatever we were trying to find out, for example, point A से point B तक जाने का जो path है, so we were not worrying about the cost of that path. This cost was never involved. So that we define something called path cost while defining our app or while modeling our AI problem as a search problem. So we define the path cost. Path cost में क्या था कि स्टार्टिंग से इस नोड तक जाने की जो टोटल कॉस्ट आपके एजेंट ने पे की है, that was the path cost, right? Starting node. So we didn't define this path cost. We in the all the algorithms that we discussed so far, BFS, DFS, DLS and ITS, इन सब में path cost का हमने कभी यूज किया ही नहीं. Even though like BFS and DFS, BFS was BFS was optimal, only if path cost is uniform. Right. So DFS was optimal when only if all the actions plus steps have same cost. Right. So for BFS, so for example, if there is this state S and there are three states, three successor states of this S1, S2, S3, and there are these three actions are possible. So BFS was all the BFS, DFS, and every other algorithm that we have discussed so far. All these are treating these algorithms in a similar manner. So for them, A1, A2, A3 are all equivalent. But this might not be case always, right? Because हो सकता है A1 better हो compared to A2 or A2 is better compared to A3. So we should give priority to A1, not A3. But this was not the case with BFS and BFS. So what BFS was doing, BFS was simply exploring all the no actions together, level by level, then move to the next level. But DFS was simply picking one action and go along with that path until we reach the end of the path and then backtrack. So this was the case for BFS and DFS. So there was no priority assigned to each action, there was no involvement of the cost and so on. So how can we how can we find out the solution in a search space where there is some cost involved? At key, how can we find out a better path? For example, let's suppose कि जैसे if we talk about this example itself, then what if this action A1 had the cost 4, A2 had cost 3, and A3 had cost 5. So now which one is better? Are all these A1, A2, A3 are equivalent actions? No, because now if we take this action A2 to our AI agent has to pay less cost to reach S2, right? We don't know कि S2 will lead to the goal or not. We are not worried about that. But S2 के पास अभी अगर आपका AI agent is in the S, तो यहाँ पे इसके पास तीन ऑप्शन है, right? Either go to S1 using by taking X A1, go to S2 by taking A2, or go to S3 by taking X and A3. So out of these three, since it has a decision to make, it can use this information कि S से S2 में जाने पे it only has to pay cost of 3 unit. Right? तो why not pick this one? Because अगर S1 पे गए तो it has to go pay cost 4 unit. S3 पे गए तो it has to go cost, so it has to pay cost of 5 unit. So it's obviously a better choice to just pay 3 unit of cost and move to S2. Then we'll figure out what to do next. So this idea of the comparison between two actions, which one is better, which one looks closer from the starting state. So this is represented using something called path cost function GN. So what GN represents? So GN represents, so for any node G, for any node N, and GN represents path cost, so represents cost of path till node N from starting or initial state. So this GN is the cost from the starting step till the current node N. तो जो भी actions की cost है, it's a total, it's a sum of all those actions or the cost of all those actions. For example, this is my, if I take this state as an S1 as an initial state, so this is my initial state, and it has two successors possible, S1 with action A1 with cost 3 S2 with action A2 equal to cost 5. S1 also has another successor called S11 with cost, let's say, action 3, 4, and let's say S21 action 4 equal to 2, and that's for there is this goal node which is reachable from the action 5, which has cost 1, and action 6 which has cost 3. So let's suppose this is how our state space look like. So this is the goal node. So if I talk about the gn value for different states, so what will be g of s? What g represents? G represents ki for any node n, gn represents the cost of path till node n from the starting state. So g of s what will represent? Ki it will represent the cost of path from in starting state to s. So since s is the starting state itself, so the what will be the cost? 0. Since खुद तक जाने का cost क्या है? 0. तो g of s will be 0. What about g of s1? तो s1 का पाथ क्या है स्टार्टिंग स्टेट से? तो the path s1 has a s and s1 which is just one step path. So what will be the cost for this? 3. So g of s1 will be 3. Similarly, g of s2 will be 5 since there is only one path from, sorry, only one step path from s to s2. So g of s2 will be s2 s path which has the cost 5. Let's talk about what about g of s11? तो g of s11 में क्या है? तो s से s11 तक का क्या पाथ है? s to s1 to s11. Right? This is the path we have from this one. So what will be the cost for it? It will be the 3 plus 4 equal to 7. Now, if some of you might be thinking, what if we consider a different path or like a path like this starting state, say S2, then go to S21, then goal, and then go S1. So if we talk about this path, yes, this is also one valid path, and g of S11 can also be sum of all these actions. That is also perfectly valid. So we'll always pick the node with minimum, like we'll try to find out the path which has the minimum value of this. But yes, this is also a valid path. You can take this one. So for now, right now, I'm trying to find the key minimum कौन सा आ सकता है. इसका भी एग्जाम्पल हम देख सकते हैं, राइट? कि जैसे जो S21 के क्या है? S2 S21 which is 5 plus 2 again 7. Now let's talk about the goal. What will be the g of goal? So g of goal would be कि goal तक के क्या path है. Now we are in dilemma कि there are two paths, right, for goal. So there is path 1, which is S to S1 to S2 S11 and goal. And if we talk about the cost along this path, it will be 3 plus 4 plus 1, which is 8. And again, if we talk about the other path as S2 S21 goal, so what's the cost along this path? 2 plus 3, which is 10. So for reaching goal from starting state, we have two paths, right? Either one and this one, second one. This is the first one, this is the path 2. So of course both are valid path and we can choose any of them, but what will be our preference? Key, let's go over the path which is the lower cost, right? So we'll pick the path which is of the lower cost, this one. So that is the idea we are gonna use. So, so this idea of finding the path with lower cost using this path cost function, this idea is captured by the algorithm called uniform cost search. UCS. The UCS stands for uniform cost search. Yeah, the name doesn't really do the justice because this uniform cost search might look like the idea of BFS, since BFS works with the uniform cost, but the name, so instead of worrying name, the what's the general approach here, we'll again work with our approach that we have discussed in the last lectures. We'll start with the frontier containing the initial state. Okay, we'll start. So what will be the implementation of frontier? This implementation of frontier will be done using something called priority queue. Why? Because now we want to expand the node which has the lower value of this gn, right? So UCS explores the nodes based on the lowest value of the path cost. So अगर जैसे फ्रंटियर में बहुत सारे नोड्स है तो इट विल पिक द नोड जिसके लिए पाथ कॉस्ट की वैल्यू सबसे कम है. So and we'll keep repeating that. So frontier will be implemented using priority queue. Again we'll start with an explored set or closed list. The frontier का क्या नाम था वो, open list. Then if frontier is empty, we'll return that key no solution has been found because we have explored all the nodes and we are still not able to reach the goal node. So we already know that. Remove a node from the frontier. So जो यहाँ पे removal का part है, that will be based on G. तो remove a node from the frontier, तो कौन सा node remove होगा? Node with lowest value of path cost gn. तो given अगर multiple nodes frontier में तो we'll always remove the node which has the lowest value of the gn. If that node is a goal node, then we'll return that we have found the goal and we'll return the solution. Solution will be path from start to goal. So that is our solution. That's how we are defining the solution. अगर नहीं है, if not, then we'll go add node to the explore set, expand the node. So what do you mean by expanding the node? We'll simply add the resultant node और जो भी इसके successors है We'll add those into the frontier only if they are already in the they are not in the frontier or they are not in the explored set also. So when all the nodes which satisfy this criteria as key, they are not in the frontier and they are not in the explored set, then we'll add all those nodes into the frontier again to explore those nodes, right? So we know this general approach. So only thing that changed here is the introduction to this priority queue. जैसे BFS के लिए it was queue, DFS के लिए it was stack. So for UCS it is priority queue. तो priority queue क्या होता है? Priority queue simply stores nodes the data in a key value pair. So to understand priority queue, simply you can think of priority queue as a container. This priority queue exact implementation will be using that. We'll talk about those later on. So priority queue, you can think of priority queue as a container which stores the key value pairs. So what are these key value pairs? So here this key will use key as a node and will use value as a or path post till that node. Okay, so exact तो priority queue क्या allow करता है? So whenever we are removing a node from the priority queue, it will allow the removal of the node with lowest value. जैसे क्यू क्या क्यू क्या अलाउ कर रहा था कि जो नोड पहले आया है वो रिमूव होगा. स्टैक में क्या हो रहा था, जो नोड पहले सबसे बाद में आया है वो रिमूव होगा. यहाँ पे प्रायोरिटी क्यू अलाउज रिमूवल ऑफ द नोड विद लोएस्ट वैल्यू. दिस अगर जिसकी लोएस्ट वैल्यू होगी तो दिस वैल्यू और यू कैन call it as a priority also. So will allow the node with the lowest priority. And insertion is simply अगर आपको आइटम इंसर्ट कर रहे हो तो वी कैन सिंपली अगर ऑलरेडी वो आइटम एग्जिस्ट नहीं करता है तो दैट विल बी इंसर्टेड. बट अगर ऑलरेडी आइटम एग्जिस्ट करता है तो उसकी प्रायोरिटी विल गेट चेंज. कि अगर जैसे अगर कोई आइटम है जैसे let's perform a sequence of actions. Maybe that will help you understand or how priority works. So let's suppose कि I perform an action called push 2, 3 or let's push a, 2. So what is this key? We need to put node A with the value of priority 2. So let's insert that. So we can, so I'll denote this as a with cost 2. You can simply insert that as a tuple also, but we look it more to note it more visually cool. So there it is. Then if we insert another node key, push b=1, we'll insert b=1. And if I now remove pop, so which item will be removed? Since b has the lower cost, now b will be removed from the frontier. Now again, if I do push c=3, I can insert c with cost 3 And if you again do push a equal to 1, so since now a is already there, right? So it's not like we can add duplicate values. But and technically, if you see this, we are not allowed to add anything into frontier if it is already existing. But here, instead of like creating a new copy, what I will do is since a I'll check कि a की already priority क्या है. A की already priority है 2, and what we are inserting 3. Sorry, 1. So that means कि we are updating the priority, or we are saying कि we have found something, we have found a better priority for A. So why not just update that? So what we'll do, instead we'll remove the A from the A which we inserted last time, and what we'll simply update the priority of that. Now A, we found a better priority for A, which is 1. But now if you do pop, what will remove? We'll remove the node A with priority 1. So this is how our priority queue works, and that's all we are needed for this course. The exact implementation of the priority queue are done using by something called binary heaps. So it is more like a heap. So this may be we have the max heap or min heap. So this exact implementations are done using this, and or we all there might be other implementations also like background linked list or any other data structures. So we'll not worry about that. You That's the thing you must have studied in your algorithms course or in your data structures course and so. And if you want, you can directly use lots of programming languages provides the implementation of the priority queue, so you can use those for your purposes. So we are not gonna go into the details of exact implementation of the priority queue that you can find check online, or maybe we can discuss in some other lectures. But this is based on your DS course or algorithms course. Okay. So now that we know about this uniform cost search algorithm, let's do an example of it. So let's talk about a very famous example of the Romania, and let's try to solve it using the priority using the UCS, and let's see which path do we get to choose, or which path will find here. So in this, remember this is the initial state, initial state, and this is the goal state. Okay. So what do we need to maintain? Let's maintain our frontier. So we can maintain our frontier like this. What is this frontier? Priority queue. Okay. Or what else do we need to maintain? We need to maintain a visited set or explode set. Explode set or visited that कुछ भी नाम हो सकता है. And then another thing that we need to maintain is our search, just to keep track of paths that we found. Okay, so what we'll do, our algorithm is simple. We'll start, so we'll start with the initial node, the A. So we'll start with A being into different step. तो A के लिए gn की वैल्यू क्या होगी? Since it is the initial state signal, so we'll have the gn value 0, right? So so we'll have the n value equal to 0. So now what? We'll remove one node from the frontier. Remove one node from the frontier. Mark it in the explode set and add into the search tree. Now what? A के जो भी successors है, तो A के successors है. This is my A, and A has three successors: S, T, and Z. तो S की cost क्या है? What's the GN value for S? तो it will be R से S तक जाने की cost which will be 140. तो GN value will be 140. T की cost क्या है? 118. That's this cost. And Z की cost क्या है? 75. So we'll add these into our frontier. So let's add these into the frontier. S with 140, T with 118, and Z with 75. Now what? Again repeat, remove nodes with the lowest value, right? So always remove node with lowest GN. So which one will be removed? Z. Remove Z. Market visitor. And since ये Z किसके थ्रू ऐड हुआ था? A के थ्रू. Will add Z and Z के जो भी सक्सेसर्स है, तो Z के सक्सेस क्या है? Already है. तो if we explore this Z, what will be the successors of Z? Z will have the successors. So if we explore Z, Z will have successors already. Or since A is also successor, but A is explored, so we'll not worry about it. So A is also successors, but it will not worry about it because A is already explored. So let's talk about this O. What will be the cost of this? So this will be cost of A to Z प्लस Z to O. तो A to Z कॉस्ट क्या है? 75, जो इसकी कॉस्ट थी. तो O की कॉस्ट क्या होगी? 75 प्लस 71, which will be 146. So let's add O with one for cost of 146. So now back to our removal node from the frontier with the lowest cost. तो अभी lowest cost कौन सा है? T. Removal node T. Explore the, तो T किसकी वजह से ऐड हुआ था? A की वजह से. तो let's add into the frontier of, let's add as a child of A in the search tree, and लेट्स एक्सप्लोर द टी। तो टी के लिए क्या क्या है? फॉर टी वी हैव द एल, राइट। तो फॉर टी वी हैव द सक्सेसर एल। तो फॉर टी वी हैव द सक्सेसर एल। तो टी की कॉस्ट क्या थी? 118। तो एल की कॉस्ट क्या होगी? 118 प्लस जो टी से एल जाने की कॉस्ट है विच इज 111। So this will be 9 to 229. So let's add the L with the cost 229. L with 229 cost. Okay, let's clear. So we'll add L with cost 229. Okay. Now what? Again remove the cost node with the lowest cost, which will which S. So remove S. Add it into the frontier. Oh, sorry, explode set. एंड ये एस किसकी वजह से एक्सप्लोर हुआ था? ए की वजह से। तो विल एड एस टू दिस एक्सप्लोर सेट। ओके, नाउ एस के क्या क्या नेबर्स है? लेट्स टॉक अबाउट द नेबर्स ऑफ एस। तो एस के नेबर्स है ओ, राइट, दिस इज ओ इज here, then F and R. तो even though O is in already in the frontier, we'll still check कि इसकी कॉस्ट हम अपडेट कर सकते हैं या नहीं कर सकते, राइट। तो एस की कॉस्ट क्या थी? 140। तो O की कॉस्ट क्या होगी? 140 प्लस S से O तक जाने की 151 which is 192 291 and we realize that कि O तक जाने की ऑलरेडी हमारे पास जो कॉस्ट है which is 146. So we'll not add O into the frontier again with the higher cost because that's the point. We already have the better path to reach O compared to the path from A to S and S to O that is more costly. So we'll not add O into the frontier. What about F? Since F is not in the frontier already, so we'll have to add it 140 plus 99, which is 9 3 2 239. Yes, 239. So let's add F with 239. And what about R? R के लिए क्या होगा? 140 plus 80, which is 220. So let's add R with cost 220 here. Again, we'll again repeat the same process of removing a node with lowest cost. So what will be the lowest cost node? Which is it will be O. Remove O from the frontier. Market visited O, and since O किसकी वजह से ऐड हुआ था? O ऐड हुआ था Z की वजह से. Let's add into the frontier. Add into as a child of the O, so child of Z, and O के जो भी neighbors है, let's add them into the frontier. तो we'll realize कि here we'll export this. Will ओके ओके कोई भी नेबर ऐसे नहीं है जो ऑलरेडी विजिटेड सेट में नहीं है, राइट। क्योंकि ओके नेबर्स क्या क्या है? Z and S both all are explored set in the explored set, so there is no neighbor of O which can be added into the frontier, so we'll not do anything else on the O. So what's the step. Again, remove a node from the frontier which has the lowest priority. So let's remove R with priority 2 to 9. Add R into the front explode set, and ये R किसकी वजह से ऐड हुआ था? S की वजह से. तो let's add R to the S. Okay. Now R के कौन कौन से neighbors है? R has two neighbors, P and C. Right. So let's explore our R. So R has two neighbors, P and C. Well, S is also a neighbor, but all S is already visited, so we'll not worry about that. So what's the cost of R? The cost of R was 220. So cost of P will be 220 plus 97, which will be 317. And for C it will be 220 plus 146, which is 366. So let's add those with this. Since these are not in the frontier, so let's add P with cost 317 and C with cost 366. Now what we'll do? We'll again remove the node from the frontier which has the lowest cost. तो अभी lowest cost कौन सा है? L with cost 229. तो mark L as a listed and L किसकी वजह से ऐड हुआ था? T की वजह से. तो let's add L as a child of T in the search tree. And let's explore L. So if we explore L, L के क्या neighbors है? L has only one neighbor and L की cost was 229. And तो M की cost will be 229 plus L से M तक का जो है this 70, which is 9 299. So we'll add M with cost equal to 299. Now what? Again remove a node with lowest cost, which is F of 239. So add F into the explode set, and F किसकी वजह से ऐड हुआ था? S की वजह से. तो let's add that also. अब F के कौन एक सक्सेसर का, that is B. तो let's explore F. F की का सक्सेसर B. तो F की cost was 239. तो B की cost क्या होगी? 239 plus 211, which is 450. So let's add B with cost 450. Okay. Now again we'll work with the same criteria of ours. Remove a node. So now which node should be removed? M, because it has the lowest cost, 229. So remove M. Mark M as a visited one. तो we have stored M. M किसकी वजह से ऐड हुआ था? L की वजह से. तो let's add M here. And M का कौन सा neighbor है? M has only one neighbor, D. So if we explore M with cost D, तो M की cost क्या थी? 299. So D is cost will be 299 plus 75, which will be 4 7 374. Okay. Let's add the D with 374 cost. Again, remove a node P. Right. So remove a node P, mark it visited, एंड ये P किसकी वजह से ऐड हुआ था? R की वजह से, राइट? तो लेट्स ऐड P here एंड P के क्या सक्सेसर्स है? तो P has two successors C and B. C की कॉस्ट क्या होगी P के थ्रू? P की कॉस्ट थी 317, तो C will have the cost 317 plus 138, which will be 455. तो is it a better cost? We check that कि C के लिए already cost जो available है frontier में, that is 366, which is through R itself. So we'll not take this path to C because we have already have the better path from R, right? So we'll not update the cost. So what about the B? तो B के लिए cost क्या? 317 plus 101, this one 101, and now there is this. Now this is an issue, right? Because this is 1,418 and B के लिए already cost क्या थी? 450, which was along this path of F to B. But now we have found a better path for B from P, right? So what we'll do, we'll update the cost and we'll update the path की जो B अब add हो रहा है, that is being added through P, not F. So let's update the cost of B, which will be 418, and the path जो B जिसकी वजह से add हुआ था, now this becomes this, not this one. Okay, now let's continue with our algorithm. Remove the node. So which node will be removed? C 366. Market and visited. And C किसकी वजह से ऐड हुआ था? R की वजह से. So let's add it to the C. Okay. And C के कौन कौन से neighbors है? C has two neighbors, P, but that is already visited, so we'll not worry about that, right? So if I explore the C has two neighbors, P, but that has one already visited, so we'll not worry about that. Another node is D. So let's check whether D के लिए cost जो C से आ रही है वो better है या नहीं. So what was the C's cost? It was 366. तो D के लिए जो cost क्या आएगी? 366 plus 120, which is 684, 486. और D के लिए already cost क्या है? 374. That means कि for D we already have better path from M, so we'll not go along this path. So we'll not update the cost for D. Now again we'll repeat the same. Let's remove D, which is with 374. Let's remove D, market visited, and D किसके through add हुआ था? M के through, because the path is through M. So let's add it to the M, and D के कौन से successors है? D has only one successor C, but C is already visited, so we'll not add anything. So D has been cleared. Now to remove B 418, that is what? A goal node. So this is the goal node. तो we know that कि वैसे जैसे goal node मिलता है, we'll simply return the solution. एंड सॉल्यूशन क्या होता है, पाथ से, स्टार्टिंग स्टेट से गोल नोड तक का जो पाथ है। एंड तो व्हाट वाज दिस पाथ, ये बी किसके थ्रू था, पी के थ्रू। तो द पाथ दैट इज बीइंग रिटर्न्ड बाय द एल्गोरिथम, पाथ स्लैश सॉल्यूशन जो रिटर्न होगा दैट विल बी ए एस आर पी बी। एंड व्हाट विल बी द कॉस्ट ऑफ दिस विल बी, कि कॉस्ट क्या थी बी की, जिस कॉस्ट के साथ we updated, that was 418. So this is the cost of this path, and we realize that ki this is the shortest path till, this is the shortest path from A to B. So our UCS will give you optimal solution, right? It will return the optimal path. So if you talk about the properties of the UCS, so what are these four properties that we were talking about? Completeness, optimality, time complexity, and space complexity. So completeness, is it, is your wishes complete? Yes, it is complete only if all the actions have some a minimum amount of cost, because UCS के साथ क्या हो रहा था कि if we are picking a, we are selecting a node with the lowest GN value, right? So if we have something like this starting node, then there is this goal node on one action with cost 1 8. But if we have this sequence of states with zero cost, so you will realize that our UCS will keep start with this, then pick this one, then this one, and keep going this path until infinity. So if there are infinite nodes such that just like this, then will be the problem, because our algorithm will not able to find a solution, because it will keep expanding along this path. So to avoid this situation, we'll always assume that there is at least epsilon cost attached to each action. So, so there will become some time, जैसे for example taking this epsilon, there will come an sk node, sk, which will be like k times epsilon, and this will become greater than equal to 8, and that's where we'll expand this g, right? So इस केस में what will be the k, this will be almost like 8 times epsilon. So this many steps it, so this will be the number of steps at least अपने यूसीएस को जाना पड़ेगा, उसके बाद it will be able to find the solution. So because of this key, there should be this minimum cost attached to each of the this. Completeness is defined like yes, only if there is a minimum cost epsilon associated to each action. We are saying that no action is free. Okay? Optimality, yes, it will return as the optimal solution. और टाइम कॉम्प्लेक्सिटी क्या होगी, सिंस एल्गोरिथम को एटलीस्ट 8 बाई एप्सिलॉन और जो इसकी कॉस्ट है, लेट इन जनरल लेट मी गिव दिस कॉस्ट से स्टार, तो इस कोस्ट तक इतनी स्टेप्स तो लेनी पड़ेगी, तो दी स्टेप्स क्या होंगी, सी स्टार बाय एप्सिलॉन, एटलीस्ट दिस मैनी स्टेप्स इट नीड्स टू टेक। तो कितने नोड्स ये एक्सप्लोर करेगा, the number of nodes being explored by algorithm will be c star by epsilon, and that is also time space complexity. Okay, since all the nodes need to be stored in different. So these are the properties of the UCS. So it is complete, but only if there is minimum cost epsilon associated with each action. So this epsilon is a smaller value. You can take any value, epsilon being a very small value, but it should be there. It shouldn't be case like there are a sequence of actions which results into the zero cost, because that will lead into the endless path for the UCS, and UCS will keep searching or keep going along this path because there is no cost involved, और जो cost है वो already हमेशा C star से कम रहेगी, इसलिए it will keep searching that path and never reach the solution. So we need the epsilon cost at least, ताकि कितने भी steps के बाद at least after these k steps एल्गोरिथम को जो cost मिलेगी that will be greater than C star, तो उस केस में it will move to the goal. That optimality, yes, it will return us the optimal path. We have seen this like above example also, and we can prove this optimality by contradiction if someone wants. So this can be proved by contradiction. that can that you can do by yourself. Key why this assumption, you can work with this assumption key whenever you, this is the claim, it is proof needs a claim. So what is the claim? Whenever UCS removes node from frontier, shortest path till the node has been already found. तो जब भी UCS किसी किसी नोड को फ्रंटियर प्रायोरिटी क्यू से रिमूव करता है, दैट इट ओनली रिमूव्स दैट नोड जब उस तक उस नोड के लिए शॉर्टेस्ट पाथ मिल चुका है, एंड तो जब भी अगर जब गोल रिमूव होगा तो दैट मीन्स कि गोल तक का शॉर्टेस्ट पाथ हमें मिल चुका है. You can claim this using a proof by contradiction. Okay? You can prove this using proof by contradiction if you want. You don't need to, but if you want, you can prove. Okay, so with this, we'll end our lecture here, and we'll continue in the next lecture with the more examples of these algorithms like BFS, DFS, and then after that we'll start with the informed search algorithms, where we'll have some extra information about the problem statement to solve the